Studying the universe is the study of origins. How was the cosmos formed? How did the galaxies emerge? And the stars and planets? Questions of profound importance and the goal of some of the most advanced research mankind has ever engaged in. Telescopes are the primary tools of the astrophysicists. Most telescopes register the light from distant stars and galaxies. Other telescopes capture different kinds of electromagnetic radiation from the depths of the universe. Radiation in the millimeter wavelength domain, for example. Analysis of this emission from deep space allows us to study the very first galaxies in the universe. It also provides a clearer look into regions where stars are formed, enabling scientists to gain insights into the complex processes that govern the birth of stars and planets. Millimeter astronomy is a young branch of astronomical research, but one of the most vital for future progress in our understanding of the universe. This is why astronomers are now considering the construction of an excitingly powerful giant array of millimeter telescopes. ALMA, the Atacama Large Millimeter Array, will be located on the high-altitude Llano de Chajnantor, 5,000 meters above sea level east of the village of San Pedro de Atacama in Chile. It's a unique site which provides exceptionally good conditions for millimeter astronomy observations. The planned array comprises 64 12-meter radio dishes, providing a total collecting surface of no less than 7,000 square meters, larger than a football field. The shape of each antenna must remain extremely precise under all conditions. The overall accuracy of the entire surface of one antenna, 12 meters in diameter, must be better than 25 micrometers, 1/3 of the diameter of a human hair. The combination of a large collecting area and such high precision results in extremely high sensitivity, allowing the detection and measurements of radiation even from the most distant objects. All of the telescopes are movable, and together they can all follow the motion of an astronomical object as it traverses the sky. In this way, the entire ALMA array functions as a single telescope of up to 10 kilometers in diameter. It will yield images that are as sharp as those of the best giant optical telescopes, such as ESO's Very Large Telescope Array. At present, the partners of the ALMA project include the US National Radio Astronomy Observatory and ESO, the European Astronomy Organization, as well as national science organizations in some of ESO's member countries and in the United Kingdom. Japan may also join in the collaboration, making it the first truly global facility for astronomical research. Specialists from Europe, the US and Japan are already working together during the extensive site testing activities at the Chajnantor site. The meteorological conditions as well as the observation conditions at radio wavelengths are constantly being monitored. The tests include daily launches of radio sonders to probe the atmosphere. In addition, variations in water vapor density in the atmosphere are monitored by means of interferometers, observing signals from a communication satellite in geostationary orbit. Already now, the substantial amount of data obtained by the site testing teams demonstrate that this remote, high-altitude desert site is clearly the most promising site for the new telescope array. To protect the pristine environment of Chajnantor, the Chilean government has declared a large part of the Chajnantor area a scientific preserve. According to current plans, ALMA will be realized in the course of the coming decade. When finished, it will become one of the most important observational tools for world astronomy. As a true child of the new millennium, ALMA holds great promise for a better understanding of the universe and its origins.